Introduce to you a fellow chemist and our Chancellor, Mr. Philip R. Marshall.
Thank you, Dr. Radke, members of the audience, faculty, students, members of the Stevens Point community. It is indeed an honor and a pleasure to be here on this campus and to serve as the Chancellor of an outstanding university. I am deeply honored and pleased by the invitation to return to the Middle West. I must confess I have been warned that the winters will not change because I am here. Nevertheless, we are most happy, Helen and I, to join this community and to work with you, with the faculty, staff, to make a very good university even better. I have now, I believe, made one decision in 1 week on this campus. The decision was to send someone to pick up Professor Commoner, to drive him from Madison to Stevens Point. I did not arrange for the fog, which was in Madison this morning, and I'll leave it to your imagination as to how I knew we must do this. It will be necessary for me to make one more decision before I leave this platform, and I will have to warn you right now, that light will have to be off when Dr. Commoner speaks. Now, if that's the wrong place for the camera without that light, then you will have to move it somewhere else. I have been honored in a variety of ways since I have been here. Interviews, articles in the paper, in the Stevens Point Daily Journal, in the Pointer. My name has been variously spelled. I am not too sensitive about it. When I get a check with 2 L's in Philip, I sign it just as if it had been with 1 L. But if anyone is interested, my name has 2 L's in Philip, lover of horses. 1 L, I am sorry. The reason I said that is because you all got an invitation, or your spouses got an invitation with the 2 L's. Obviously, I'm not sensitive. Sometimes I can't remember myself. 2 L's in Marshall, 1 L in Philip. After 1 week on campus, it is indeed an honor for me to participate in Convocation 2, as a part of that convocation, to honor one of our outstanding teachers. Mark Cates has many outstanding attributes. Among them is that he was born in Indiana. One cannot do everything right, however, and he went to Indiana University. Mark well knows what Boilermakers do with the IU fight song. And I'm afraid Wisconsinites know what Boilermakers do on the football field. Nevertheless, I am told that Dr. Cates is a truly outstanding teacher, that he has once before been the recipient of this award for excellence in teaching. And it is a pleasure for me to honor him and to honor the University of Wisconsin-Stevens Point in so doing. Dr. Cates. It is also an honor to introduce the speaker for Convocation 2, Professor Barry Commoner. For more than a quarter of a century has been the social conscience of the scientific community, a spokesman for scientists to the lay people of the United States and of the world. When I, about 25 years ago, visited St. Louis to visit an individual who is, in fact, a mutual friend of ours, a classmate of mine in college, Dr. Commoner was already well known for his activities in the scientific community, in particular, in this instance, the investigation of fallout from nuclear explosions. And he was one of the few in the beginning who pointed out the dangers of strontium-90 and other decay particles from the nuclear explosions. He has continued throughout the intervening years to speak with fervor, with flamboyance on occasion, with accuracy, to his beliefs and the beliefs of many in the scientific community concerning the direction that technology was taking us. He is the author of several books, including The Closing Circle, The Poverty of Power, and most recently, The Politics of Energy. He is University Professor of Environmental Science at Washington University in St. Louis. He's Director of the Center for the Biology of Natural Systems. As I was leaving graduate school, my major professor admonished me that in professional life, certainly the best thing was to receive acclaim from my peers. Second best would be to receive criticism from my peers. Certainly one would not want to be ignored. And above all else, Professor Barry Commoner has never been ignored. It's a privilege and pleasure to welcome to this audience Professor Barry Commoner, who will speak on the politics of energy. Professor Commoner.
Thank you very much, Dr. Marshall. It's an honor for me to be here, partly to welcome Dr. Marshall. I think I was in Stevens Point before he was. I drove through here 2 weeks ago, having spent a week not catching fish up north. And I'm already acquainted with perhaps the second most prominent activity in Stevens Point, because I've come to admire and use Point beer. I think this is a wonderful thing that you have here, a convocation to open the year, because it's a good idea to figure out where you're going. particularly since I think the country is now at a turning point which is going to make an enormous difference in the ability that you're going to have to contribute to the country's development. I think that the next year is going to see real changes in the direction in which the country is going. At least I hope so. And I think it's very important that you have an opportunity to think about that so that hopefully when you're ready to contribute to what the country is doing, the country will be ready for you. It makes a big difference whether here at Stevens Point you're learning how to use resources wisely when you get ready to go to work, what the country wants you to do is burn them up as fast as possible and make a quick profit. And so I think it's very important that we take this occasion, and I'm delighted to have this opportunity to participate in it. I think it's important that we realize that the country's in deep trouble. All the trips down the Mississippi and wise meetings at Camp David can't cover up the fact that most of the conditions that determine how people live are deteriorating. You know, in the last 20 years, we've had a faster increase in the cost of living than we have ever before. I mean, the fact is that people now have trouble buying a home or renting a place to live. There is no end to inflation in sight. Here in the wealthiest country in human history, there are people who can't find jobs. The American working men, the American working women have lost ground as inflation has eroded their wages. A decade after Martin Luther King, blacks and other minorities are still struggling for their rightful position in our society. Better housing, job training, national health care, the rebuilding of our cities, all of these things that people talked about a decade ago is something we have to do. All this remains a mirage. At the same time, the government has enough military might to kill everyone on earth several times over. And yet, we are talking about building new nuclear missiles, inventing new fancy ways to bury them under the ground where they ought to remain. Women's rights are still under attack. The ERA is stalled. The average woman, if she gets a job, is lucky and then earns 60% of what a comparable male will earn. The point I'm making is that people in this country feel, and I think rightly, that the dream of a growing economy, a rising standard of living, improved freedoms, civil rights, this vision has been replaced by the vision of austerity, of declining standard of living. Something obviously has gone wrong, and that's what I want to talk about, because I think that we have the opportunity now to make it go right. Now, I'm going to talk about energy, and the main reason is not that energy is all that important. It's that the energy crisis, the energy aspect of this general crisis gives us a marvelous opportunity to understand the crisis as a whole. And that's really what I want to talk about. Now, all of the problems, I think, are illuminated by the way in which we have failed to make sensible use of our energy resources. Let me just remind you about a few fundamental facts. Energy is absolutely essential to everything we do, and there are good scientific reasons for it. And if I can take 30 seconds to go through the science of thermodynamics, I think I can make it clear. If you look up energy in a textbook, you'll see right away they stop talking about energy and talk about work, because energy is a source of work. And if you look up the definition of work, you'll discover that you're told that it's a force exerted through a distance. So how does that explain the trouble that we're in? Well, let me very quickly give you a different but equally accurate scientific definition of work that will begin to help make sense of this. Work is what you have to do if you want something to happen that won't happen by itself. For example, getting out of bed in the morning. Now, you can do the experiment, or perhaps you have, of just lying in bed. Don't do anything. And I promise you, you will not get out of bed. The reason is that getting out of bed is a work-requiring process, and it won't happen by itself. A rolling downhill will happen by itself. And if you get on top of a hill and start rolling, you'll find you'll go down. You can do that experiment too. Now, if you stop to think of it then, if everything that we want done that doesn't happen by itself, for example, getting me from Madison to Stevens Point, that took work. In fact, I had to get out of bed this morning. That was the hardest part. If all of these things take work, and in fact, the only way to get work done is for energy to flow from one place to another, usually from a hot place to a cooler place, then energy is essential for everything that we want to happen. That doesn't happen by itself. In other words, you want a car? Well, it doesn't happen by itself. I defy you to make piles of steel, glass, rubber, and copper, and then sit around and wait for the car to be assembled. Work has to be done. Work by people, work by machines. And so every aspect of our productive life fundamentally depends on energy, and all of our worldly goods, all of the economic gain in our productive system, therefore, is dependent on energy. But in order to get the energy source out of the ground, in order to get oil out of the ground, work has to be done. It doesn't come out by itself. You have to drill holes, you have to pump the oil. So part of the resources that we produce with energy have to be fed back into the task of gaining energy, of converting the energy into work. For example, you have to build an engine to make the energy in the gasoline convertible to the wheels turning so I could get up here from Madison. In other words, energy is essential to the production of all of our wealth, but some of that wealth has to be diverted back into the process of producing the energy, converting it into work, and so on. Now, why is there a crisis? It's actually quite simple. You've been told quite a few things which make it seem very complicated and elusive. For example, Mr. Carter made that famous speech about the moral equivalent of war, and he said very grandiloquently, "We are running out of oil." Now, I want to make a simple point. President Lincoln in 1860 could have made the same speech. It would have been equally truthful for President Lincoln to say, "We are running out of oil." And what Mr. Carter said was also truthful, but irrelevant. Irrelevant because the issue is not that why could Lincoln have said it? Because the first barrel of oil was taken out of the ground in the United States in 1859. And I can assure you, the minute you take a barrel of oil out of the ground, there is less left, and you're running out. And so in 1860, we were running out of oil, and in 1977, we were running out of oil. And we will continue to run out of oil. What's the problem? The problem is oil is a non-renewable resource. That's why we're running out of it. That means when you use it, there's less left. Every time you take a barrel of oil out of the ground, there's one barrel less left. The important thing is not that there's less there. The important thing is that the price, the cost of producing a non-renewable resource, and here I'm going to get scientific again, rises exponentially with production. Now, this is an extremely important point, and I want to take about 30 seconds to make it clear. What I'm saying is that, incidentally, 96% of the energy that we use is non-renewable. What I'm saying is that the mass of the energy we use, because it is non-renewable, rises in cost, rises in price, exponentially as we use it. Okay? For example, let's take the price of U.S. oil, domestic oil, at the rate at which it's been increasing in price over the last 10 years, and when I say price, I mean discounting general inflation. That is, the uninflated price has gone up so fast that whereas in 1970 it cost $3.18 a barrel, in 1980 it'll cost at least $5 a barrel. And at that rate, it projects to $14 in 1995, $70 in 2020, $380 in 2045, and $2,000 in 2070. In other words, that's what an exponential curve means. Now, why is this happening? And it's inevitable as long as it's renewable. Well, let me remind you something about exponential relationships. The most common one is, of course, earning interest in your bank account. You put $100 into the bank at 6% interest. That shows you how old-fashioned I am. In a year, you get $6 in interest. Now you've got $106 if you keep it in the bank, and then you get 6% of $106. And if you wait 100 years, you will have, instead of $100 in the bank, something like $30,000, and you'll be getting more than $2,000 a year in interest. This is the old gag about the $24 that was spent, was it $24 to buy Manhattan from the Indians, would now be, I don't know how many zillion dollars. That's exponentiality, okay? Now, the important thing about an exponential relationship is that the process keeps changing. The balance in your bank account keeps getting bigger, so when you apply a 6% rate to it, it keeps going up even faster. Now, let me explain this about oil, and I want to use what I call my Italian analogy. I spend a certain amount of time in Italy, and I want to explain why a non-renewable resource being depleted has to go up exponentially in price. And suppose I gave you a bowl of spaghetti, and I tell you there are no seconds. It is now a non-renewable resource, right? Okay. And we ask the following question. In fact, you could do this experiment in a physics class. Suppose I say, look, the spaghetti in the bowl will not get into your mouth unless you work. How do I know that, class? You put the spaghetti there and do nothing, and it stays there. That's the test that work is required. If you don't do anything and nothing happens, then work is required. Try it. So, I ask the question, how much work does it take to get a forkful of spaghetti from the bowl into your mouth? During the entire exhaustion of the bowl, I want to know how much work it takes to get the first forkful, the second, the third, and the last. Okay? Now, I can tell you what will happen. Maybe you can do the experiment. Is that allowed? You know, you measure the force that it takes to lift the how many grams of spaghetti and so on. Here's what you're going to discover. That as you take the spaghetti out of the bowl, it takes an exponentially increasing amount of work to get a forkful out. The first forkful is very easy. You just go, yep, there it goes. The last forkful, you spend quite a bit of time scrambling around in the bottom of the bowl to get a forkful, right? Now, why is that? That's the question. And the point is this. Every time you take a forkful of spaghetti out of the bowl, you have changed the character of the bowl. It is now more difficult to get the next forkful. And that's exactly what happens with oil. Oil is in large pools, small pools, shallow ones, deep ones. The large, shallow ones are taken first. The result is that every time you take a barrel of oil out of the ground, you automatically make the next barrel more difficult to get. You have to go deeper into smaller pools with more wells and so on. And that's why a non-renewable resource must, regardless of how nasty the oil companies are, even if they make enormous profits, it is still a fact that the cost of producing that oil is going to rise exponentially with time. Now, why have I belabored you with this mathematical idea? Because this is the energy crisis. You cannot have a stable economic system which depends on a source of energy that requires part of the economic output to produce it if the cost of producing it rises exponentially. There is no way that an economic system can continue to operate with its essential resource eating more and more of the economic output of that system. And what is happening today is very simple. The exponential rise in the cost of energy is cannibalizing the rest of the economic system. Now, you don't have to go to economic textbooks to see that. You talk to anyone now, and certainly this is happening in parts of the country that are cold, like Wisconsin. You talk to anyone now, and they will tell you that the cost of paying their utility bills is eating up their resources. In many parts of the country, people now spend more on utilities than they do on rent or mortgage on their home. It is becoming the largest part of people's expenditures, and what do you get out of it? You get out of it the same heat that you got before. In other words, simply to maintain a household as a functioning place, or to maintain an industry as the place where goods are produced, now is taking a larger and larger part of the wages and of the output of the economic system. And I tell you very simply, there is no way that this can continue very long. Why? Because this is the driving force of inflation. You can do a very simple exercise. Go to this marvelous book called The Statistical Abstract of the United States, which has lots and lots of information in it, and make a plot, make a graph of the cost of energy, which is in there, going back to 1811, as a matter of fact, and the cost of consumer goods. And what you'll discover is that the price of energy has been constant over the years until about 1971, that inflation was slow until that point, that starting in 71 and 72, the curve of energy cost began to rise exponentially, and from then on we went into double-digit inflation. Now, is that a surprise? No. Everything requires energy, and therefore, as the price of energy goes up, the price of everything else goes up. This has a disastrous effect on the population because it turns out that poor people are more dependent on energy than rich people. Now, what do I mean by that? If you look at a family's budget and ask what part of the budget is needed to buy energy, you'll find that for the poorest fifth of the families in the United States, at least a quarter of the budget now goes into buying energy. For the richest fifth of the family, it's about 5%. Richest fifth families of the richest fifth in the country. The reason is, again, simple. The necessities of life, which poor people spend an awful lot of their budget on, are very energy intensive. Getting to and from work, which is a necessity of life, means that you have to expend a lot of energy. Food, which is now very energy intensive, both the production of food, the preparation of food, that is also a part of the energy budget. Take clothing. Many people wear polyester, synthetics, made out of oil and natural gas. And as the price of oil and natural gas escalates, the price of clothing escalates. In other words, That is the energy crisis. It is the fact that the non-renewability of our present resources, oil, natural gas, coal, and uranium is non-renewable. Their costs are rising exponentially, eroding the economic system and the standard of living, and driving the country economically to the wall. That's the energy crisis. Now, it's, I think, fairly simple, but very difficult to recognize. You may remember that before Mr. Carter discovered inflation, he went around the country saying, why don't people understand that we're running out of energy? And what were people telling him? Our utility bills are going up. He says, that's not the point. We're running out of energy. The rising utility bills are the point, because it's fundamentally connected to the non-renewability of energy. Now, I don't want to berate you with all these problems. I want to say what we can do about it. And let's go through that. If, in fact, the problem is non-renewability, then we have to go to renewable sources of energy. That is, unlike the bowl of spaghetti, sources of energy which do not get used up as you produce it. Now, what are the possibilities? Some people talk about fusion, the reason being that fusion would use as a source of energy hydrogen from the ocean. And there's so much hydrogen in the ocean that you wouldn't make a dent on its availability as you used it. Now, I'm going to set that aside immediately. Why? Because fusion doesn't exist. It's a good idea, but it hasn't been done. Now, why do I set it aside? Because if it is true that to avoid an economic disaster, probably in the next 10 years, we have to start shifting over to a renewable source of energy, you darn well better know that it exists. Because suppose we say, yes, we're making a transition to fusion energy, and 20 years from now it turns out it won't work. Now, it's like building a bridge across a chasm without knowing where the other side is. And so however good an idea it is, I set it aside. There are two existing sources of renewable energy. One of them is nuclear power. If you introduce the breeder reactor, the present nuclear power plants will run out of uranium in 25 to 30 years. You all realize that this big stuff that they're all trying to ram down our throats will be all finished in 25 to 30 years unless we're willing to build completely new types and riskier nuclear power plants. The breeder would generate more fuel as it operates so that the uranium resources would last not 25 years, but about 2,000 years. And I'm pretty conservative, and I'm willing to let 2,000 years stand for the future. So I would accept that if it worked. But it doesn't work. We now know that nuclear power is what I might call an immature technology. Like any immature individual, it causes trouble. The reason, incidentally, and I don't want to spend a lot of time on that, the reason is that it turns out to be a foolish way to boil water. You understand that the only reason for using energy is to do work, right? And the only reason to do work is to perform a task, getting out of bed, for example, right? Well, the task in a nuclear power plant is what? Boiling water to make steam to run the electric generator. That's the task. Now, there are other ways of boiling water, I assure you. And what is involved with nuclear power is using an inappropriate source of energy to the task. For example, suppose you want to warm the baby's milk bottle. Well, the way you do it is to put it in some warm water. Now, you could warm it with a blowtorch, but it would be very costly in milk bottles and is not an appropriate way to do it. Well, what I'm saying is the whole idea of using nuclear power is so inappropriate that most of the problem has been rising costs, trying to tame the inappropriateness, trying to contain the radiation, and so on. And I'm not going to make a big speech about this. I just want to read to you a statement from an investment counselor, a man who counsels investors in utilities, Saunders Miller, who's in Minneapolis. He's made his living by telling people which stocks to buy in utilities. And he wrote a book called The Economic Cost of Nuclear and Coal Power. And here's the concluding paragraph. The conclusion that must be reached is that from an economic standpoint alone, to rely upon nuclear fission supplies nuclear fission as the primary source of our stationary energy supplies will constitute economic lunacy on a scale unparalleled in recorded history and may lead to the economic Waterloo of the United States. Now, I'm not that radical, but I think he's right. I think that if we continue to use nuclear power, it will wreck the economy. And the reason is that the attempt to tame this inappropriate source of energy keeps costing more and more money. Why is it that 4 years ago, 36 new nuclear power plants were ordered, last year, 2? Why is it that the utilities that use most nuclear power are the ones who've had their bonds derated at Wall Street? Because this is a risky economic venture. But let me make a very simple point. The most avid proponent of nuclear power agrees that we could not have nuclear breeders in place because we haven't built any. Incidentally, those of you who think that Mr. Carter is against the breeder have another thought. Well, as a matter of fact, he's now explained it very carefully. When his national energy plan came out, it was 2 weeks after he had announced that he was against the breeder being built at Clinch River, Tennessee. In the nuclear plan, in the national energy plan, is a little sentence which says, Mr. Carter favors alternative types of breeders, that use uranium-233 instead of plutonium. The point is this: no matter what, no breeder can be built in less than 25 years. That means if we go to that, we want to go to that as a renewable resource, we will have to suffer this exponential rise in the cost of energy for 25 years, and my own opinion is the economic system wouldn't stand it halfway through. In other words, what we need is a renewable source of energy that can be put in place today. Otherwise, we're in deep economic trouble. And of course, the other alternative is solar energy. Now, immediately you'll say, well, that's for the year 2000 and into the future. There's been a lot of nonsense about the impracticality of solar energy, and let me quickly make a couple of points about it. First, let me define it. Solar energy is energy that comes from the sun. I think that's clear. That includes not only the warmth that you get when you put your hand or a solar collector in the sunshine, it also includes wind. Now, where's the energy of wind come from? There isn't anybody out there blowing. What it is hot air rising because of heat from the sun and cold air rushing in under it. So wind is solar energy. You and I are now expending solar energy. Most of the heat in this room is solar energy that you're putting out and I'm putting out. Where did it come from? Well, breakfast, right? Where did the breakfast come from? Came from plants or animals, but the animals got their stuff from plants. Where did the plants get the energy? From the sun. All organic matter, such as you and me, represents solar energy. And there are other ways of converting sunlight directly into electricity. Point is, all of these things represent solar energy. Now I want to make another basic point about solar energy. Solar energy, and incidentally, some people say, well, you know, it's so diffuse, it's all over, that it's hard to know how you're going to run a factory on solar energy. Well, let me make a point about this diffusivity. Power plants are big, nuclear plants, coal-fired plants, because of what economists call their economy of scale. That is, the bigger they are, the cheaper the electricity. And that's important because the bigger they are, the more money you have to spend to transmit the energy. 70% of the capital invested in our electric power system is in the transmission system. So the bigger the plant is, the more you better have an economy of scale to overcome the cost of transmission. Now, solar energy has no economy of scale. If you want to get a lot of solar energy, for example, a simple way is to have a photovoltaic cell that converts sunlight into electricity. You want a little power. I have a solar device which, for some crazy reason, is a dancing hamburger. It's a plastic hamburger. This is an in-joke about, because I once did something about carcinogens in hamburgers. Anyway, what it is a little plastic hamburger with a photovoltaic cell on it that drives a motor that makes the thing dance. And you put this thing out in the sun and the hamburger dances. That's solar energy. Now, the important thing is this. If you took a few hundred of those things and put them on the roof of your house, you'll begin to get useful power. But the efficiency of each little cell is exactly the same, and it will not be more efficient to have a big one or a small one. That means that it makes no sense to collect more solar energy than you need, because then you'll have to transmit it at a cost that you cannot meet. In other words, solar energy should be gathered in the amount and in the form needed to carry out each local task. That brings me to a slogan that I want to give you about solar energy, which is very important. A lot of people think that solar energy is a panacea, that if you're for solar energy, you're a good person. I want to tell you this. It is entirely possible to be in favor of solar energy and stupid at the same time. And I'll give you two examples. One is the satellite that's being proposed to gather solar energy, beam it down in microwaves, which will probably fry every bird and airplane going through, and then collect it in one place and disseminate it. In other words, a huge central power station. Now, fortunately, that hasn't been built yet. But we are building in Barstow, California, a central power station made up of a huge field of mirrors focused on a boiler which will make steam and make electricity. That is, again, an example of being solar and stupid at the same time. It always reminds me of this old thing that the archaeologists tell us, that the first basket makers, when they learned how to use clay, made pots and then imprinted the basket weave on it because they thought that was associated with the containerability of the thing. It's the same cultural lag that you see in a modern automobile. Look at the plastic upholstery in your automobile, and you will see imprinted in it stitches, fake stitches, right? Well, it makes as much sense to imprint fake stitches on plastic as it does to build a central power station out of solar energy. So that's another point. Now, a lot of people say, well, that's all well and good, but it's impractical, it can't be done now. Well, let me give you a couple of very simple facts. In most of the country today, a whole series of government reports have shown that the use of solar collectors. What's a solar collector? It's a tin box that's painted black in the bottom of the glass lid. You put air into it and it gets hot. You take it out, warm your house. You put water into it, it'll get hot. You can use that too. That's called a solar collector. In most of the country, solar collectors would now be economical for a householder to put on their roof, to provide most of their energy, not all, but most, and you would get the return on the investment of $15,000 to $20,000 over the next 15 years in reduced energy costs. That's economically feasible. People will say, well, that's silly because, you know, that's fine for houses, but what about electricity for industry? Well, let me go to the other extreme now. Let me take the most advanced kind of solar energy, converting sunlight into electricity, and tell you that that's economically feasible today. How? Well, this is a photovoltaic cell, which is a silicon crystal that's sliced and sandwiched between some metal grids, and when sunlight falls on it, you get electricity. Does it work? Yes. The famous satellites that keep falling on us are powered by photovoltaic cells. When you see a TV broadcast by way of satellite, there are photovoltaic cells that are doing that. What's the trouble? Well, the trouble is that they're very expensive. $10 a watt. At that rate, a 10-watt bulb would mean a $1,000 investment. A 100-watt bulb would mean a $10,000 investment. Obviously, it's out. Well, can you bring the price down? Well, 2 years ago, the Federal Energy Administration did a study in which they showed that you could bring the price of photovoltaic cells down in the same way that the price of the devices that now run the $8 computers that you can buy was brought down. You know, the so-called integrated circuits, chips that go into computers. In 1960, those chips cost $50 each, and nobody could afford to buy them. That's wrong. We all could afford to buy them because we paid taxes and the Department of Defense bought them to put in missiles. And the entire industry in 1960 of integrated circuit chips was devoted to so-called defense. Okay? In this case, for missiles. Well, the FEA did a very interesting thing. They asked the Department of Defense, again, could you replace some of your remote electric power stations, you know, to run telephone circuits and so on, with photovoltaic cells? And they did a big study and came up with a figure of about 150 million watts worth of photovoltaic cells that they could use. The FEA then turned around and went to 2 manufacturers of photovoltaic cells and said, look, we know they now cost $10 a watt, but what will you charge the government if we give you an order of 150 million watts? Incidentally, the amount manufactured at that time was about 200,000 watts a year. So it would be a huge expansion. What will you charge us over the next 5 years if we give you the order? And the answer came back in the following way. In the first year, we'll charge you not $10, but $3 to $4. In the second year, $1, and in the 5th year, 50 cents. Now at $3 to $4 a watt, the government would save $500 million by replacing 20% of the Department of Defense remote power installations. But more important than that, farmers who want to irrigate at a distance would do it cheaper than they are now doing. And in the third world, developing countries at that price could have power systems cheaper than they could by building central power stations. In fact, the UN has now offered an open contract to any company that will supply photovoltaic cells at $3 a watt. At $1 a watt, photovoltaic cells become cheaper to use for lighting parking lots and roads than conventional utility electricity. At 50 cents a watt, it invades the residential market because it becomes cheaper in the Southwest. And from then on, it invades the rest of the country. A marvelous thing to do. You know what it would cost? $440 million to buy those photovoltaic cells to trigger off this industry, and it would save the government $500 million. Have we done it? No. And in fact, this report was suppressed by the Carter White House, but congressional people learned about it. Some of us got copies in plain brown wrappers. And Congress embedded in the National Energy Act a requirement for buying $98 million worth of photovoltaic cells, which would do the job pretty well, but slower. Carter had to sign that act. That was his great achievement, such as it was. And when he signed it, he did an absolutely unprecedented thing. He attached a statement to it saying that he would not authorize the expenditure of those photovoltaic cells. Immediately afterward, the largest company building these things in the U.S. wrote a joint contract with an Italian firm, Mont Edison, and the world's largest photovoltaic cell plant is going up outside Florence, Italy, which will quintuple the world production of photovoltaic cells. Now, what I'm saying is very simple. We are very likely to get economic photovoltaic electricity buying the equipment from Italy and probably Japan. Now, does that make sense? No. And it points out that not only is this, see, what would take it? Carter's signature would have put photovoltaic electricity into the U.S. economy. It takes only a stroke of the pen. Now, what I'm saying then is, yes, it's feasible. Another very important thing about solar energy is that you must give up the idea that we're going to do this by some enormous revolution, that here we are doing all these stupid things, and the scientists are going to develop these nice things to do, and suddenly, on one day, we'll switch from being dumb to smart, and everything will all be happy ever after. Can't do that. The reason is you must not interrupt the flow of energy no matter what. That's a disaster. So you have to have a transition which takes us from where we are now to where we want to go, gradually replacing the existing non-renewable sources with solar energy. In fact, you've got to use solar energy to solve today's problems. And I want to quickly give you an example. Again, a marvelous missed opportunity. As you know, one aspect of the energy crisis is gasoline lines. Now, why are there gasoline lines? You now know that there was no shortage of oil. That's now been reported. During the last episode, there was no shortage of oil. What was the trouble? The trouble is that the refineries were unable to produce enough unleaded gasoline. There was no shortage in leaded gasoline. The number of days of stored leaded gasoline was normal. Unleaded gasoline fell down by about 75% in the amount stored, and so distribution problems arose. Now, why was the problem? Well, in the last few years, the government has mandated an increase in unleaded gasoline in order to get lead out because it's poisonous and poisons the catalysts and the smog control devices, and also because we have mandated an improvement in the mileage of American cars. To do that, Detroit is raising the compression ratio in the engines, and you need octane boosters which suppress the knocking in high compression. So that the U.S. oil industry has known for several years that it's got to put in chemical octane boosters other than lead, more and more into the gasoline supply, but they failed to build the resources to do it. It's a secondary refining process, so there's a shortage. Do them something. Well, all it did, of course, was to raise the price. Now, here's the tragedy. There is a solar source of energy that would provide the missing octane boosters and do it immediately, and it hasn't been used. And what that is something that you're very familiar with if you've been drinking point beer. It's alcohol, ethanol. Be scientific about it. Ethanol is a solar fuel. Surprised? Point beer is solar energy. Let's be clear about it. Why? Because the alcohol, which is burnable, comes from corn, let's say, which has been fermented by yeast, and that carbon and hydrogen in the alcohol came from organic matter built into the corn by the process of photosynthesis using solar energy. Now, it turns out that alcohol is an excellent octane booster. And if you put 10% alcohol in 90% crude gasoline, you get an excellent high-octane fuel called gasohol. This could be done, and in fact farmers all over the Midwest, including Wisconsin, with their own money are going ahead to do this. Now some of the oil companies are beginning to market it. All that it would take would be for the government to begin to, well, very simple thing. Here's Chrysler dying on the vine, right? If we had the wit to tell Chrysler to build for single farms, for farm cooperatives, easily run alcohol stills to make alcohol from corn, we could readily end the gas lines within a year, and Chrysler would be in better shape. People say, well, you're going to interfere with food production. Not so. The present way in which we've designed our crop system is designed to raise livestock. That's what we do with most of our crops, raise livestock. As you know, to raise animals, you need a certain amount of carbon and a certain amount of nitrogen. And we have it nicely balanced by using corn and soybeans. If you replace the soybeans with sugar beets and hay, you've got enough extra carbon which converted to alcohol would replace half of the gasoline we use in the United States. Half. And a method which is now being perfected at Purdue for converting cellulose into sugar would double the production, so that in fact we could produce enough solar alcohol out of U.S. agriculture without interfering with food production to replace all of the gasoline in the United States. Why aren't we doing it? Ask the oil companies. They don't want the competition. Instead, they want synthetic fuels, making this nasty stuff that you can out of coal. But let me quickly finish, because I've told you that we have a problem which is very serious, and we have the opportunities to solve it. And the last thing I need to talk about is why haven't we done it? And I think there's a clear reason. The reason is that it will take political action that no politician is willing to face. Now, the simplest way I know of explaining it is this. At the present time, take the new synthetic fuel bills. The new synthetic fuel bills are what I must call anarchistic. They represent anarchy. Read them. Here's what it says. The government is going to put $140 billion to produce various kinds of fuels, and the decision as to what fuel will be made by nobody. What do I mean? They say the free market will determine which fuels ought to be made. If they're profitable for somebody, they'll go in and do it, and then the government guarantees to buy it. In other words, the idea that the free market will determine what we do has got Washington in its grip, and I call that anarchy. Why are the railroads being destroyed? Because railroads do not make a profit that competes with other investments. And the result is that wherever you have an unprofitable branch line, it's closed down. That's happening right here in Wisconsin right now. In October, the government plans to cut Amtrak by 40% because it's supposed to make a profit. Every European country has a better railroad system than we do. Why? Because it's nationalized and they all run at a loss. Where is it written in golden tablets that a railroad must make as much profit as a winery, let's say? So the railroads take their capital and buy wineries. Now, what I'm saying very simply is this. The problem in Washington is that the private interest in making profit determines what we do rather than the national interest. And what this means is not only anarchy in decision-making, but a death of what I would call a death of politics. Now, you know what's been going on in the country. You choose candidates by how flashy their teeth are and how wavy their hair, and who they go out with to Africa. Does anybody ask, what do you stand for? Can you tell me the difference between the Democratic Party's and the Republican Party's position on energy? It's impossible. Now, the strange thing is we went through a period like this before in this country. before the Civil War. Do you remember the names of the presidents before Lincoln? No. Buchanan, Polk, Tyler, Harrison. I know them because I looked them up. These are the nonentities in the history of America. This is what historians call the ignominious age of American politics. The campaigns were Tippecanoe and Tyler too. You know, if they had TV, it would all be the boob tube stuff. Instead, they had picnics and so on. Why? Was the country free of problems? No. The reason was that none of the political groups were willing to talk about the basic issue, which was slavery. When Lincoln wrote his speech to debate Douglas and wrote into it opposition to slavery, his friends told him, "Take it out, Abe, you won't get elected." He left it in, and he lost the election. Now, here in Wisconsin, at Ripon, the Republican Party was born in order to make the country face that basic political issue which it had been avoiding over the years. And I think we're in the same situation today. I mean, ask where, you know, all right, Kennedy says Carter is incompetent and he'll be more competent. Brown says that he's for nuclear power, but at the same time he's for austerity. In other words, we're not seeing any consistent policy toward the energy crisis or anything else out of our political leaders. The reason is that the parties have lost their ability to deal with the basic issue. And what is it? That the national interest in a solar transition, in rebuilding the economy on that basis, is being suppressed by the private interests of the corporations. And the problem that we face in the country today is to at last make the interests of the people, the national interest, the dominant determinant in what we do. And that is the lesson of the energy crisis. Thank you.